Hi guys, in this video, I'm going to explain merge sort and then we'll take a look at the code at the end of the video. So we have this array and we want to sort it from the start until the end, such that afterwards the array will be from least to greatest. The first thing we're going to do is determine the middle. So the middle is equal to the floor of s plus e divided by 2. So what is s? Well, s will be 0, right? S will be 0. This is the index. It goes from 0 to 4. So s is at 0. So 0 plus e, and e is 4. So 0 plus 4 divided by 2. And then we have to floor this, right? And I'll show you how this works in a second. So this is equal to 0 plus 4 is 4 divided by 2 is 2. And then 2 rounded down is just 2. So the middle will be right here. The next step is to divide this array. So we're going to divide this array into two halves. On the left, we have 5, 3, 4. So we divided it from s to m inclusively. So 5, 3, 4. And then over here, we have 1 and 2. And then we're going to repeat this process. So here will be the start again. And here will be the end. And then this is the start. And this is the end. So the second step is to calculate the middle. So the middle will be equal to the floor of s, which is 0, plus 2, divided by 2. So this is just the same as the floor of 1, which is just 1. So the middle is right here. As for this one, the middle will be s is 3, plus the n is 4. So 3 plus 4 divided by 2, we will get the floor of 3.5, and the floor just means round down. So after we round down, we're going to get 3. So the middle for this one is right here. Then we will divide these arrays. So this is what we will have, and we're going to repeat the process again for this one. So this will be s, this will be e, and this will be m. If there is only one number left, we no longer need to divide it. And we will divide this last one. And we are almost done. So as you can see, all the numbers are divided and these subtrees only have one element left. Now we're going to merge them. So starting here, 5 and 3, how are we going to merge it? Well, let me show you how to do it. We will have 3 and 5. So after we merge it, we'll have 3 and 5, and it's in order. And then we have to merge these ones. So 3, 5, and 4. And then we'll merge 1 and 2 together. And finally, we will merge our entire array. And that is basically merge sort in a nutshell. Now let me explain it in more details. There are two parts to merge sort, and this is the first part. So merge sort, we take in an array, we have start and end. And then if the start is less than the end, then we calculate the middle, then we merge sort again, starting from start until mid. And then we do merge sort again, starting from mid plus 1 to the end, and then we're going to merge everything together. So let's go through this merge sort step by step. So the first thing we're going to do is have merge sort. We're just going to call it ms. And then we take in the array, so the array, and the start is at 0. The start is at 0. The n is at 4, so 0 and 4. Then we're going to do this one right here, because start is less than the n. So we calculate the mid, and then we do the merge sort from here. Alright, so that merge sort is going to be ms, and then we put in the array again. And this time it's the start. The start is going to be 0. The middle is going to be 0 plus 4 divided by 2. Which gives you 2. So the mid will be 2. And then we're going to do this one right here. That would be merge sort. And we pass in the array. Then mid plus 1. So mid plus 1. So 2 plus 1 is 3. We have 3. And then we have the n. So the n is going to be 4. And now we're going to do the merge part. And we're just going to call it m this time, the small m. And we pass in the array. So the array, then we have the start, which is 0. the mid is going to be 2, and the n is going to be 4. Now we're going to repeat the same step for these ones right here. Okay, so now we have merge sort, and then we have the array, we have the start, which is 0, and the n is 2. So is the start smaller than the n? Yes. So we will begin doing this one, which is the mid. We calculate the mid. Then we do the merge sort. So merge sort, we pass in the array. Then we have the start, and the start is 0. Start is 0. And the mid is 0 plus 2 divided by 2. So 0 plus 2 is 2. 2 divided by 2 is 1. So the middle is 1. The mid will be 1. And then we will do this one. So merge sort. We pass in the array. We have mid plus 1. So mid is right here. So 1 plus 1 is 2. And the n will also be 2. And then we will merge everything together. We have the array. Then we have the start, which is going to be 0. Then the mid is 1. Then the n is going to be 2. We will do the same thing for this one. So we have the array, then this is the start, this is the n. Now, is the start smaller than the n? Yes, it is, because 3 is smaller than 4. So we're going to calculate the middle, and then we do the merge sort. So merge sort, we pass in the array, we have the start, which is just 3, and the middle. So 3 plus 4 is 7. 7 divided by 2 is 3.5, then we round down, we get 3. So the middle will be 3. And then we do this one, so merge sort. We get the array, the mid plus 1 is 3 plus 1, which gives us 4. And then the n would just be 4 as well. And then finally, we do the merging. So merge, we pass in the array. The start is 3, the mid is also 3, and the n is going to be 4. Then we will do the merge sort for this one. So is the start less than the n? Yes, because 0 is less than 1. We calculate the mid, and then we do the merge sort. So we get merge sort. And then we pass in the array. The start will be 0. And how about the mid? Well, 0 plus 1 is 1. 1 divided by 2 is 0.5, and you round down, so you get 0. So the mid will also be 0. And then we do this merge sort, so ms. Pass in the array. Then mid plus 1. So 0 plus 1 is 1, then the n will also be 1. And then we do the merge. So m, we pass in the array, we get the start is 0, the mid is 0, and the n is 1. Then we take a look at this one. Now the start is less than the n, so is 0 less than 0? No, it's not. So this is done. Then is 1 less than 1? No, it's not. And then this is the merge. We're going to talk about this later. So this is assuming it's done. So this one is done. And then how about 2? Is 2 less than 2? No, it's not. So this is done. This is done. This is also done. This is done. Done. And so this is also done. This is done. And this is done. So this is the complete diagram for merge sort. And now we're going to talk about the merging of the two arrays. So how does it work? Well, let's find out. Now, quick recap. We start merge sort here, then the recursion goes this way, and then it goes this way, then it goes this way. Now, is 0 smaller than 0? No. Okay, the start is not smaller than the end, so this is done. Is 1 less than 1? No, it's not, so this is done. Now, we're going to merge these two subarrays together. So this is what our array looks like at the moment, and now it's telling us to merge 0, 0, 1. So the start is at 0, the start is here. The mid is at 0 too, so the mid is here. Then the n is 1, so the n is right here. So we're going to merge 5 and 3 together. And the first step is to create a temporary array. So we're going to have a temporary array looking like this, and the size is 2. So how do we determine the size of our temporary array? Well, it's very easy. You take the n, so this is the n, right? You take the n, so 1, and then the n minus the start. So this is the start, so 0, and then you plus 1 again. So this will give you 2, and that's how you determine the size of our temporary array. The next step is to determine I and j. So we're going to put I at the start right here, and then j will be the mid plus 1. So the mid is 0 plus 1 is 1. So j will be right here. Then we have k, and we're going to put k at the beginning of our temporary array. We ask I and j which number is smaller. And of course, 3 is smaller, right? So we're going to put 3 into our temporary array, and then we move j up. So we're going to move j up. Then we also move k up. So j moved outside of its boundary, which means that we no longer consider it. So whatever I has, we put into the array. So I has 5, we put 5 into this temporary array. Then we're going to move I up. And then we move k up. So that is how merging works. Now, we already merged 3 and 5, and this is what it's supposed to be. And the last step is to copy back this into our array. This means that after this merge, this is what our array looks like. Then our tree sees that this is finished, so this is also finished. And now we move to this one, and 2 is not less than 2, so we ignore this as well. And then we go to this merge. This merge function says to put start on 0, put mid on 1, and put the end on number 2. So what are we merging here? Well, we are merging this one with this one. So notice that this one is already merged, and it goes from start to the mid. And then this one is just the end. So we're going to put I right here at the beginning of this line, and then we put j here. The next step is to create a temporary array. And this temporary array will be 3. The size will be 3. So how did I know that the size is 3? Well, you take the n is 2, you minus the start is 0, and then you plus 1. So this will give you 3, and that's the size of our temporary array. We put k at the beginning of our temporary array, and then we ask I and j which number is smaller. Well, it's 3, so we're going to put 3 here, and then we move I up. Then we also move k up. We do the same thing, so which number is smaller? And j says, I have the smaller number, so we put 4 into here. Then we move j up. Then we also move k up. So one of them moved outside of the boundary, so j moved out of the boundary. So whatever I has, we put it into the temporary array. So we put 5 into the temporary array, and then we move I up. Then we move k up. So both of these went out of their boundaries, which means that our merge is done. So all we have to do is put 3, 4, 5 back into our array. So this merge function is done, which means that this one is done. So the recursion tree goes here, then it goes here. Now 3 is not less than 3, so we're done as well. Then this one, 4 is not less than 4, so we're done. And now we have this merge function. The merge tells us to put start on index 3, so start goes here. This is index 3. And then the mid is also index 3, so the mid goes here as well, and the end is 4. Now, what are we merging here? Well, we are merging this one and this one. So let's put I here and put j here. We're going to create a temporary array of size 2. And why is it size 2? Well, because we take 4 minus 3, so 4 minus 3 is 1, 1 plus 1 is 2. We put k onto the temporary array, and now which number is smaller? Well, I has the smaller number, so we put 1 here. Then we move I up. We also move k up. So I move out of the boundary, so whatever j has left will go into the temporary array. So j has 2, so we put 2 into our temporary array. We move j up, and we move k up. So both I and j went out of their boundaries, which means that the merge is finished. So all we have to do is put this back into our array. So this is what our array looks like after we finish this merge function. So the tree sees that this is finished, so this is finished, and now we have the last merge function. The merge tells us to put the start on 0, so index 0 is here. Then the mid is 2, so this is 0, 1, 2. The mid is on index 2, and the end is at index 4. So 0, 1, 2, 3, 4. This means that we are merging from here to here. So notice that this is from S to M inclusively. And for the yellow part, it's m plus 1, so m plus 1 until the n inclusively. So let's put I at the beginning of this, and then j right here. And we have to create a temporary array, and the size is going to be 5. Why is the size 5? Well, that's because we take the n is 4, we minus the start 0, so 4 minus 0 is 4, then we plus 1, and that's 5. And we also put k onto our temporary array. Well, which one has the smaller number? Well, j has the smaller number at 1, so we put 1 right here, and then we move j up. We also move k up. We look at I and j has the smaller number at 2. So we put 2 into our temporary array. We move j up, and we also move k up. One of these two went outside of the boundary. As you can see, j went outside of the boundary, so whatever I has will go into our temporary array. So I has 3, we put 3 here, and then we move I up. We also move k up. Then I has 4, so we put 4 here, and then we move I up. We also move k up. Then we put 5 into our array. And we move I up, and we also move k up. So as you can see, both of them went outside of their boundary, which means our merge is finished, and all we have to do is put this back into our original array. So this merge function is finished, and so these 3 are finished, so this one is finished as well. And that is basically merge sort. We're done. This array is sorted from least to greatest. Now let's take a look at the code for merge sort. Let's write the code for merge sort. So here is the first part of merge sort, and the second part is to write the merge function. The first thing to do is to set I and j and k. So remember I said before that we set I equal to the start, then j is equal to mid plus 1, and then k is just 0. The next step is to create our temporary array. So int temp is equal to new int, and the size of the array is just n minus start plus 1. Then we have to create the underline for I and j, basically the boundaries for I and j. And the boundary for I goes from start to mid inclusively, whereas j goes from mid plus 1 until the n inclusively. So that would be a while loop. So while I is less than or equal to mid, and j is less than or equal to the n. So what are we doing here? Well, as long as I and j are inside their boundaries, then we ask I and j which one has the smaller number to put into the array. Let's say that I has a smaller number. So that would be if array at I is smaller or equal to array at j, then if I has the smaller number, then we put whatever number that I is at into our temporary array. So that would be temp at k is equal to array at I. Then we move I up, so I plus plus. Else, so if j has the smaller number, then it would simply be the temporary array at k is equal to array at j. So we put the number that j is at into our temporary array, then we move j up. So we move j up, and then we move k up. So this while loop is finished when I goes outside of the boundary for the left subarray, or j goes outside of the boundary for the right subarray. If j went outside of the boundary for the right subarray, then we're just copying whatever the left subarray has into our temporary array. That would be while I is less than or equal to mid, or when I is still within the boundary, then we copy it over to the temporary array. So temp k is equal to array at I. So we copy it over, we move I up, then we move k up. Another case scenario is when I goes outside of the boundary for the left subarray, but j is still within boundary for the right subarray. So we need to copy the right array into our temporary array. That would be while j is less than or equal to n. That would be while j is still within the boundary. Then we copy whatever j has into the temporary array. So temp k is equal to array at j. We move j up, then we move k up. After these two while loops, we know for sure that both I and j are outside of their boundary, which means that the merge is finished and we need to copy the temporary array into our original array. We set k back to 0, so it's at the beginning of our temporary array. Then for I is equal to start, I is less than or equal to the n, I plus plus. Then we copy our temporary array into our original array from the start to the end. So array at I is equal to the temporary array at k. Then we have to move k up to copy the next element. There is another way though. If you do it like this, if you delete this and you do I minus start, then both methods do the same thing. So you can also do this and it will basically do the same thing. Let's test our merge sort. So we have a main method, then this is our array that we want to sort from least to greatest. Then we're going to merge sort the array starting from index 0 at the beginning until the end of the array. Then afterwards, we're going to print out the array one by one. So as you can see, our array is sorted from least to greatest. This means that the merge sort is correct. And we are almost done. So when we call the merge sort function, usually we just like to put in the array and we don't really want to put this in, right? So it's better if we do it like this so it's cleaner. And there is a way to do this. So let me show you how to do it. We just need to write public static void merge sort. And then we pass in an array of integers. And then we're just going to merge sort our array starting from index 0 until the end of the array. So you could totally do this, and that basically allows us to not write this whenever we call the merge sort function. Last but not least, the time complexity of merge sort is O nlogn for worst case, best case, and average case scenario, and the space complexity is O of n, and that's because we are creating the temporary array. So that's it for merge sort. I hope you guys enjoyed this video. Don't forget to hit the like and subscribe button if you found this helpful. And in the next video, we're going to talk about quicksort.